good morning, good night, good evening, good day to everyone. So we'll open up the presentation with the blockchain technology group. And we're co-chairs, Olga and Parmesh, of the blockchain technology group. And we want to thank you for attending SNIA Symposium. Next. So blockchain technology group was approved by SNIA Council, SNIA Board of Directors last year in June, at mid-June 2020. Here's the link to the group. And the goal of the group is to create an interoperability specification in a blockchain technology focused on data storage, primarily data storage applications. To add to this topic, a recent CoinDesk and Binance news announced that this segment of the industry's market is rapidly growing. And in the blockchain world, the data storage segment of the blockchain has been separated and now estimated to be at $5.6 billion, and it's considered to be grown from the previous year of 2.5. So it's growing almost twice in less than a year. So the focus of 2020 was on a technology review. So we spent the majority of the year on educating the members of what is the blockchain technology is, what's the value add, why join blockchain tweak, understanding the landscape of the blockchain technology, and mainly focusing on the data storage blockchain technology applications, understanding the players, understanding their implementations and architecture, and outlining the high-level architectural overview to move forward with the building and interoperability itself. And let me stress one important factor. In a blockchain, there is a lot of arguments, do you need it or don't need it, but I would give an example. In PCI world back in the day, there people were also not considering the need, but as we all know, PCI Express and other protocols are required to create a successful interoperability between devices and exchanging information at the upper levels. Same happens with the blockchain, where you need to consider not only security protocols itself, but the transferring data and communicating it with the by using the security protocols. Next. So what were the work items last year and what are the work items for this upcoming year? We are planning to finalize the blockchain architecture to start building an interoperability specification. We target to release a 0.5 specification by the end of 2021. We are planning to start working on compliance test suite specification for the interoperability testing, and we're planning and hoping and in process of establishing the collaborations on the blockchain initiatives such as ISA Linux Foundation, IEEE Blockchain, and SODA Foundation. There will be probably more up and coming such as other foundations which are active in that space. Next. This is the current membership of the blockchain as of January 20, 2021, and it's growing. If you have any questions, please reach out, and the call to action is please join, because this is a very interesting space in a technology, and I truly believe that it has tremendous potential and future, especially if your companies are looking for the business expansion. As you know, a large banks, large financial institutions are currently looking at technology itself, and just the latest news on Chase and JP Morgan and Morgan Stanley and others, the approval of the financial institutions to exchange information, and the latest government initiatives in the cyberspace are all great indicators of where for the demands of such technology.
Thank you, Olga, for the update this morning. For those interested in more, please do contact the co-chairs. The emails provided here, and you can learn more about the work of the group and how you can contribute to it by following up with the co-chairs. Thank you.
Thank you.
Okay, so I'm Mark Carlson, and David Slick and I co-chair the Cloud Storage Twig, and this is an update on our work. Next slide, David.
Sure. So 2020 was a pretty good year for our technical working group. The Cloud Storage Technical Working Group has been primarily focusing on the Cloud Data Management Interface, but our scope is quite a bit broader. Our goal for the Technical Working Group is identifying, developing, and coordinating system standards for cloud storage. This includes producing specifications and driving consistency for interface standards and messaging between cloud storage systems, cloud storage clients, and other related infrastructure. And our goal here is to ultimately document from requirements all the way through to standards and collaborating and coordinating with other standards organizations. So one of the things we've recently done is we've moved over our entire documentation workflow from a FrameMaker-based flow that was, of course, good, but fairly unwieldy given the costs and licenses and lack of ability to have collaborative and open standards creation. We've moved over to a fully open source-based documentation tool chain hosted on GitHub using a set of tools, namely Sphinx and LaTeX, to be able to build our entire specification from text assets and image assets checked into GitHub. This has been really good for us because we've all been able to collaboratively work on the documentation and take advantage of a lot of the review tools and editing tools and versioning tools in GitHub. And I encourage anyone interested in this to go and take a look at our specification. It's like 400 plus pages, all built automatically. And in addition, we've been able to take CDMI 2.0, which is the next version of the CDMI standard. This is now released on GitHub. It's got TC approval, and we are now ready for ISO submission to update CDMI ISO standard to the latest version. In addition, the way that CDMI works is that various vendors submit extensions. So we've been updating these various extensions into the same GitHub open source toolchain and checking this in, as well as continued educational outreach and video presentations through SNIA's Bright Talk sessions.
Next slide, Arnold, or Michael. So the work items that we have in the Cloud Twig is to submit 2.0 to JTC1 via the pass process. That involves us working on an updated pass explanatory report and sending that off. We've also reviewed and documented the vendor-specific or vendor-submitted CDMI extensions. CBOR representation and CDMI extension, container value CDMI extension, object exports CDMI extension, container deep enumeration extension, and S3 export CDMI extension. The little numbers there are our GitHub issues. So you can go to the GitHub repository and see what those are all about. And then we plan to work on an open API specification for CDMI that involves creating JSON schemas for sort of an electronically documented API that CDMI is. Next slide, on Michael. David?
Sure. So the Cloud Storage Technical Working Group has a pretty healthy membership. We have 27 companies that are monitoring the work of the Technical Working Group, and 10 companies that are actively participating in the Technical Working Group. And we've put up the logos of all of the companies who have been attending in the last calendar year and contributing to the standards effort.
Next slide. All right, so what is the expected industry impact of this work? Well, we want to enable interoperable cloud storage multi-cloud, cloud storage, multi-cloud data management. We appeal to cloud storage systems, both public, hybrid, and private as well. And if you want to contribute functionality to the existing specifications, we can also provide a forum for additional cloud storage standardization efforts. We welcome non-SNIA contributions through our GitHub site with the contributor license agreement click-through. And if you have any other questions, give us a shout out. David and myself can both be reached through the Cloud Twig chair at SNIA.org alias. Thank you very much.
Excellent. Thank you, David and Mark, for the update. Up next is Scott Shadley and Jason Molliard off update on computational storage. You have 5 minutes.
Good morning and good afternoon, everyone. This is Scott Shadley along with Jason, my co-chair. Give you a brief update on what's going on with the Computational Storage Technical Working Group. So if we can go to the next slide. Our charter, of course, is out there for anyone who'd like to take a review of that. We've been quite busy in 2020 with working around the concepts of defining computational storage to the market. We put some definitions out in 2019, and we made some considerable updates to those throughout the course of 2020. Our architectural document that we're currently working on has its second public release and is still out for public comment as we continue to do work within that particular document now as well. And we have also joined in the CMSI efforts and created a SIG within that, as you can see here, and you'll learn more from the CMSI team to help drive the marketing outreach of the computational storage group. We've spent a lot of time and effort working around the architectural document in the last year of 2020 and looking forward to some great updates as we show for next year. A lot of things happened within 2020 as well related to our liaison agreements with the NVMe NVM Express working group, as they also have introduced a TPAR to do definition work on what they classify computational programs. And we're doing our due diligence and making sure that we're working carefully with that team and aligning efforts as appropriate. We also kicked off several subgroups within our organization because we know that an architectural document is great, but there's an opportunity to drive things like an API draft document that we've started around how to actually manage those devices from what we classify as a user space. And we appreciate all the contributions that our team members have given to that. And we've now reformalized what we classify as security kickoff group. And we've got new contributions for that particular group, lots of things going on, especially with all the recent cybersecurity related activities. We knew and acknowledged that if we start to move a compute complex anywhere away from the CPU, we need to make sure that the participation of security is paramount within that. And then as far as the SDC presentations have gone, 2019 was great. 2020 was even greater with the fact that it was virtual. So we're continuing to see many of our member companies continue to drive and gain traction within the organization around that. So we'll go ahead and let Jason speak to the next slide on what we plan for next year.
All right, great. So lots of work still ahead of us in 2021. We are planning to get a Rev 1.0 of our architectural document released and available for public review to those working groups that Scott mentioned for the user space. We hope to have an API document. We do have an API document that we're working on right now, and we want to have that initial draft and publicly released for comment coming up here soon. On the security subgroup, lots of effort in the way of white papers and technical comment. We aren't going to try to reinvent the wheel here in security. We want to leverage what's already been done in the industry and just kind of give some suggestions on how best to use security to make computational storage successful. And then, of course, there's a potential persistent memory and CS Summit that's being considered, and so a lot of work around that and moving forward in the year. So as far as other SNIA groups are concerned, we are engaged with and monitoring the SDXI efforts, and I'm sure they'll be giving an update here soon. We've had conversations with them and expect to stay in touch throughout the year. From an external perspective, Scott already mentioned NVMe. There's been past interaction, and certainly we expect more as their TPAR or TP continues forward related to computational programs. And then from a security standpoint, ISO and NIST there may be some opportunities there as well for discussion and collaboration. So next slide. Scott, I'll let you touch that one.
Yeah, so we're very excited to see the continued growth of this working group. As you can see here, we currently have 46 different participating companies, of which 227 members exist related to tracking the information of what's going on within the working group, which is amazing. We average between 20 to 30 people a minimum per call that we have weekly. We're up to actually 3 weekly calls now, one for each of the subgroups and one for the primary technical working group, and we're going to spend all day tomorrow continuing the efforts of the TWIG itself. So you can see we have a nice breadth of contributors from component to product to end consumers and even the software aspects of the efforts that relate to computational storage. So we're very excited. We're continuing to look for new members to help drive the breadth of the base that we have going, and we also, of course, acknowledge that several of these vendors have products in the market today as well.
30 seconds to wrap up.
Okay, final slide. We just as far as the, what is it about it and why do we care? We're expected to see great things come from this. You can see in the bottom right, we've included the 2 Gartner hype cycles that computational storage entered in 2020. This is a unique one. So not only did we enter higher on the chart than NVMe did when it first joined the graph, but we also entered 2 separate graphs because we're both compute and storage. So the impact and relevance of computational is here. It's time to continue to drive the work, and we're very excited to see the growth of the market space within the next 3 to 5 years and being a significant contribution to the success of that as we continue to see computational storage promoted throughout the industry, not only by member companies, but by industry analysts, as well as third-party articles that are being written regularly on the topic. So if you have any questions, you see all the contact information here.
Excellent. Thank you, Scott and Jason, for the great update. Next up is the green storage. Don Nerb, you are up. You'll hear a chime when you have a minute left to wrap up.
This is Don Goddard talking for the Green Storage. Herb is traveling today, so he couldn't make it. Next slide. This is our accomplishments from 2020, quite a few. The Emerald spec went to ISO in 2019. In January, the Energy Star DCS stakeholder meeting, Emerald v4 was published in support of Energy Star data for data center storage version 2.0 in the summer of 2020. And the Emerald v4 complete tester kit was available. We're doing ongoing data analysis of EPA test data. We are doing idle evaluations for SNIA in conjunction with SNIA Japan on the upcoming Japan storage spec. We collaborate with the Green Grid and are in the process of upgrading our white paper on storage energy efficiency and architecture trends. We support the EPA DCS unit shipment reports and are supporting it again for 2020. 2020 is reported in 2021. Green terms are added to the SNIA dictionary. Swordfish has added some DCIM features. We're collaborating with SNIA Japan and with the Green Grid on EU Lot 9 regulatory updates. Quite a bit going on. Next slide. This is our roadmap for the coming year. There's the SNIA EPA update coming up later this week. Energy Star V2 becomes effective the 15th of March of this year. We're updating the data center's storage energy efficiency white paper Towards the end of the year, we are going to be we've done V2 data, and we will be doing V2 data analysis. Let me get that straight. The end of this year to see what the results of the new V2 are. And we're collaborating with the Green Grid on EU Lot 9 standards and regulatory updates. Next slide. This is a list of the companies that are currently members of the Green Twig as of January 14th. You can see the list there. And next slide. So what is the impact of this work? We are trying to get one architecturally unbiased test methodology to serve regulatory bodies worldwide. Proactively provide the single test methodology worldwide and become the industry knowledge of storage system consumption and best practices configurations to optimize power use without compromising system functionality. Basically, we're trying to get one standard for energy efficiency for storage. What is the segments of interest? Storage system manufacturers, storage device manufacturers, DSIM software vendors. Now, why should you be participating in the Green Twig? Participate in developing standards used worldwide for data center, data storage, power efficiency. Influence regulations worldwide related to data center, data storage, power efficiency. Refresh and renew focus on best practices. Maintain and create competitive advantage by being aware of what's coming to avoid being surprised. The main thing that's going on is coming up in the next year is Lot 9 is going to be expanding to include data storage energy efficiency standards. Those will go into effect in 2023. So if you want to be involved and know what's coming and be prepared for what you're going to have to do to be able to ship into Europe in 2023, this is the twig to be participating in. Because if you don't know what's coming, it's going to come as a big shock. If you want to contact us, you can contact Herb or I through the Green Twig email at the bottom of the page. Thank you.
Thank you, Don. Next up is the IATA twig. Jeff?
Okay, hi, I'm Jeff Kenning of the IATA twig. Go on to the next slide. So in 2020, we have primarily continued to focus on maintaining the worldwide repository for trace files. We have mirrors in California, New York, and Korea that are busily serving trace files to researchers around the world. We have a wide variety of types of traces, including block I/O traces, system call traces, static snapshots, key value stores. All of those can be found on our repository at iata.snia.org. We also have historical traces, some going back as many as 20 years. Recent additions that we have made in the last 6 months are some excellent traces from IBM, their object store system. Also, Twitter has provided us with traces of accesses to Memcached servers. And we have some recent traces of RocksDB running on solid state drives underneath the YCSB Yahoo benchmarks. All of those are new traces doing recent technology, so they continue to be useful to researchers and give people new insights in how things are being used today. We can move on. So work items for 2021, our most ongoing work item is continuing to support the repository, both in terms of posting new traces for people to use and continuing to solicit traces that have recently been collected. We're also going to announce the SNIA IATA GitHub project, where we're going to start organizing and releasing open source software tools, starting with a tool called Reanimator that makes it easy to trace and replay system calls on Linux. We also have connected with the SNIA open source liaison to collaborate on those open source projects. And all of this is open to both SNIA and non-SNIA members, so anybody can download this software and use it. We've connected also and collaborating with the CMSI people to stay abreast with CMSI related activities such as the performance test specifications. Next slide. So membership as of now, we are a fairly small twig, but we have 39 members, including companies like Cisco, Dell, Lenovo, Western Digital, Seagate, and so forth. Educational institutions, we include Harvey Mudd College and Stony Brook University, and we're also getting support from the Ulsan National Institute of Science and Technology in Ulsan, Korea, who have donated rack and servers for the mirror over there. And also NetApp has been a supporter of the twig fairly reliably. Next slide. So we've had a lot of industry impact. We have we are recognized as the #1 place to go to get traces, the most reliable source of traces anywhere in the world, especially contemporary traces. It's the place to go if you want to find recent traces. It's a one-stop shop for traces, and we've been very successful. We've had over 500 citations in research publications. All of the content is available for free download, completely unrestricted. All you have to do is fill out a simple SNIA license that basically says, I recognize that these traces belong to SNIA. If you would like to join the twig, help improve the repository, voting on future directions, monitoring new traces, and so forth, please do so. It will help us. It will help you. And if you want to contact either me or my co-chair, Tom West, you can do that at iota-twig-chair@snia.org. Okay, thank you.
Thank you, Jeff. Next up is Chris Martin, update on LTFS twig.
Hi, thank you. Yes, my name is Chris Martin with HPE, and I'm one of the co-chairs of LTFS twig. If we go on to the next slide, please. Just as a reminder, LTFS stands for the Linear Tape File System, and the goal of LTFS is to provide a tape format that removes any dependency on hardware or software platform that's actually sending the data, so that bulk data can easily be transferred in an interoperable way, and also provide archival storage for large amounts, really large amounts of long-term cold data. So the LTFS format specification describes how data is written to tape cartridges with periodic XML indexes that are written in line describing the blocks on tape. In terms of our accomplishments last year, our focus really was on completing and updating the 2.5 format spec with some editorial cleanup, and that's resulted in version 2.5.1 now available on the SNIA website there. LTFS format spec is also published as an international standard, and 2.2 was published back in 2016 by ISO. So during 2020, we worked to prepare and send the updated 2.5 spec to ISO with the goal of replacing that older version, because there have been a number of new features added since 2016. I have to say it's been quite a slow process, but we are heading towards publication later this year. Perhaps we go on to the next slide. So we have two open work items. First one is the development of an LTFS compliance test specification. So this will be a spec that describes how an LTFS implementation can demonstrate compliance to the 2.5 standard. The LTO consortium, the manufacturers group, has donated a previously proprietary document to SNIA, and the twig will be working to clean that up, convert it into the SNIA format, and then enhance for the latest format changes. Basically, that describes some initial data sets and a series of operations to be performed on the data by an implementation, and also the expected tape layout after it's been completed, so that we can check that cartridges generated will comply with the expected format and so meet that goal of interchangeability with implementations from other vendors. So alongside that, we're also working on a way of representing the tape format as a flat set of files, so that compliance can be demonstrated by exchanging file sets without needing to ship cartridges physically around the world. Because we're anticipating much smaller data sets than would fit on a physical tape, that seems to make sense, and it's sufficient to demonstrate all aspects of the format. I guess it's important just to say that we're not setting out to prove tape drive interchange. That's a given. That's assumed and is responsibility of the manufacturers. Next slide, please. Just to show the member companies of the TWIG, there are 2 co-chairs, which is myself and Takeshi Ishimoto-san from IBM. A number of other member companies there. Fair to say probably most of those are dormant members, and we're always welcoming further participation. So if we could go to the final slide, it really would be good to have more folk and companies joining to help push this forward. LTFS is already in wide use in a number of industry segments, anywhere where large amounts of data need to be stored for the long term. And it's relevant to anyone who's grappling with storing that ever-increasing amount of data and wanting to migrate off of faster but more expensive and power-hungry forms of storage. Tape does provide the ultimate air gap because cartridges are physically removed and stored securely. But because they're removable, it's essential that the content written is demonstrated to be interchangeable and implementations interoperable. So that's what we're really seeking to demonstrate by developing this test spec and the supporting pieces like the image format. So feel free to get in touch with either of us as the co-chairs, and we look forward to further contributions to LTFS. Thank you.
So the Object Drive TWIG is chaired by myself, Mark Carlson, and Bill Martin. Bill, you want to take it away?
Yeah, if I can remember to get off mute. Welcome to this segment. And we did 2 things in 2020. The first of those, actually, we rolled a couple of revisions of the native NVMe over Fabrics drive specification. We did 2 things there. One of them is we helped to drive the form factor and pinout discussions, or primarily the pinout discussions, for the native NVMe OF drive, so that you can have a drive that plugs into a connector from any manufacturer and have the same pinouts for a native NVMe OF drive. So we released that spec in June of this year. The other thing we did, we had 2 releases actually of the key value storage API specification this year. That specification is in support of the key value standard that was developed in NVMe to provide a key value interface for storage to the host. And a key value interface, for those of you who aren't familiar with that, allows you to address your data by a key and return your data, which is the value, and it gets away from the block storage paradigm. So those were the 2 accomplishments we had this year. Next slide, Michael.
So the work items that we have going forward are to update the native NVMe OF drive specification. What we're waiting on is the SSM TWIG work on Swordfish for NVMe. And that work is proceeding, and Rochelle will talk about that work a little bit more. Next slide. Bill?
So we have 25 companies that are participating, or at least that are on the rolls to watch what we're doing. We have a few major contributors and a number of onlookers, and we hope that you will see some value in what we're doing and join us as well. So Mark, go on with the next slide.
So what is the expected industry impact of the Object Drive TWIG? The API for key value implementations allows open source libraries for NVMe key value drives. Those are available, I think, from Samsung website, right, Bill?
Yes, they're available on open source from Samsung.
Okay. And then the Object Drive TWIG, as Bill mentioned, has defined a connector pinout and management interfaces for those drives. And this allows a new segment of the industry, Ethernet drives, to be out there in the wild, built into data centers, etc. The standards that are being driven by the Object Drive Twig are important to any developers of NVMe, for example. If you want to join and participate in this twig, please consider joining the twig to continue defining infrastructure for connecting NVMe OF and any possible KV API updates. That's it.
Thank you both. Rochelle?
Thank you. And Mark did a lead in for some of the stuff I'm going to be talking about here. I'm the chair. This is Rochelle Olvers. I'm the chair of the Scalable Storage Management Twig. Next slide. We've been working for about 5 years now on effectively rolling out Swordfish, the Scalable Storage Management specification and API. We have a lot of deliverables in conjunction with that. Last year, we basically have started partnering with DMTF and NVM Express to jointly deliver a bunch of content. So we had a joint release in August that rolled out support across both organizations with content supporting NVMe, and we're in the middle of adding a bunch more that Mark just alluded to, and I'll talk a little bit more about that. So SNIA.org, we have bundles that have expanded. Initially, it was just a spec, schema and registries. It's expanded to include profiles, the user's guide, and in the last year, we've added an error handling guide and an NVMe model overview and mapping guide. We also have supporting material both on swordfishmockups.com. We also have a practical guide that we deliver. There's an open source software site where we've had several bits of content. In the last year, we added the Swordfish PowerShell toolkit. And next slide. So a lot of stuff going on there. This year, we're again continuing our focus with NVMe. So we have some new profiles and coming out that are focused on adding support and explicit profiles for all of the different NVMe product configurations. We are releasing the NVMe drives that cover different permutations of NVMe drives, and that's again working in conjunction with the Object Drive Twig, NVM Express, and DMTF to deliver all of these. And those will actually be used by the Swordfish CTP program. So this year, the Swordfish CTP program will be able to support both traditional block storage as well as NVM devices. And after we get that release done here, which is basically should be rolling out next month, we will be looking and collaborating with the NVM Express and DMTF to support a bunch of new NVMe and NVMe OF. And along with that, we're expanding support for that into yet another collaboration that expands on that work with the OFA, which is the Open Fabrics Alliance. So that basically builds on a lot of this work that we're doing with NVMe OF, which has been around one particular fabric type to cover and expand across basically support for all different types of fabrics. So there's a lot of work building on each other that is the focus of the work for this year. And of course, enhancements to support implementation feedback. Next slide. We have about 29 member companies, 120 members, a lot of active participation. We have this week is, last week and this week are a bit of an outlier because about 10 hours of meetings trying to get virtual face-to-face in, since we didn't have time for a real face-to-face at the annual symposium. But we do have about 3 hours of regular meetings a week between Twig meetings and our standing NVMe virtual or NVMe face-to-faces. Next slide. What we're really looking at in terms of industry impact is, supporting the ecosystem for standards-based storage management. Our targets are really all types of external storage, which is the shift for Swordfish. So everything from server-attached storage, cloud-based hyperscalers, traditional external storage, and we're seeing growth and interest in a lot of that space. We see also participation across the board, from storage vendors, client application developers. We have a broad target for those we want to see actually participating and who we do see participating. We'd like to encourage folks to join the TWIG to contribute either new or modify existing content, focus on improving interoperability, adding support for new functionality, or simply accelerating your own implementation. If you're not ready to do that yet, please just join to monitor the content and discussions. We have a lot of folks, obviously, out of that 120 that are just monitoring what's going on. If you need any additional information, please contact me at ssmtwigchair@snia.org. Thanks.
Thank you, Rochelle. Eric, you're up for an update on security.
Thank you. I'm Eric Hibbert, and I am the chair of the Security Technical Work Group. This work group has been around for quite a while, going back to 2000 timeframe. I think it's the first time we saw materials come out of this TWIG. Our program of work is broken down into basically 4 areas. So general storage security. We do a lot of work with SNIA architectures and specifications. So a lot of the previous sessions that you've heard, we engage when needed on security aspects, dealing with securing storage ecosystems, and last but not least, information retention, preservation, and discovery. So like, for example, ISO's e-discovery standard was something that we paid attention to. For this year, we did quite a bit of work on a TLS specification for storage systems. This basically is a TLS profile that's actually used by CDMI and a couple other specifications. So we've done an update on it and essentially prepared to move to TLS 1.3, which is a significant change. So this is intended to get ready for that change when the inevitable black swan event occurs that says TLS 1.2 is no longer viable. In addition to working internally, this year there were quite a bit of work with international standards, and you see 27040, which is the storage security standard. It's undergoing revision, and we are definitely engaging on that front. I mentioned earlier electronic discovery, so this deals with things like preservation, retention. NIST came out with a storage infrastructure document earlier this year, and SNIA provided a significant number of comments and contributions on that. And then IEEE is actively developing a standard on sanitizing storage, and again, SNIA is engaging on that front as well. We also keep an eye on the data security and legal terms in the SNIA dictionary, which also show up in various standards, including ISO. Next slide, please. Looking forward to 2021, the TLS specification I mentioned, there is an ISO equivalent of that, which is 20648. We will be updating that standard in the not too distant future. Publication is probably going to be later, late 2021. The 27040 standard is actually going to be around for quite a bit of time. It takes about 3 years to do a revision or develop an ISO standard. It's early stages, so there's probably another 2 years on this. This is a significant change. The document's going from a guidance standard to a requirement standard. In other words, conformance can be measured, and it's written from the standpoint of consumers of storage technology. So SNIA is actively looking at this, both from a vendor perspective, what do the vendors potentially need to do, as well as trying to help out with the consumer piece. Likewise, the IEEE standard for sanitization will be a heavy focus area. We have a collection of white papers. Many of those were referencing the 2015 version of the storage security standard, and we will be going through and updating those. Think of that as a sort of forward look of what we anticipate will be of the new version of the 27040 standard. We'll definitely be dealing with storage concepts in collaboration with other organizations in SNIA. And we always keep an eye on NIST draft publications, and where appropriate, provide feedback on that. We're anticipating there's probably going to be 2 or 3 that'll come out in 2021. We collaborate with most or all of the SNIA activities. Security and privacy are cross-cutting, so that does pull us in on a regular basis. We also have pretty active collaborations with a couple of insights committees, CS1, which is dealing with cybersecurity, T11 Fiber Channel, T10, SCSI, the IEEE Cybersecurity and Privacy Standards Committee, and the Trusted Computing Group. Next slide, please. We have a lot of organizations are keeping an eye on our activity. You see the asterisks. These are organizations that have pretty active participation in the last year with the Security Technical Work Group program work. Next slide, please. All right, so from a Security Technical Work Group participation perspective, what's our impact? Well, we definitely produce educational materials, best practices as well as formal standards. The best practices piece is important because the standards may actually describe or define particular approaches, but in some cases it may be difficult to realize that, or you need additional details. So that's something that TWIG definitely works on. We're dealing with consumer and users of storage technologies, as well as vendors, developers, and implementers. So pretty broad spectrum of how we look at things. If you're interested in participating, we have a weekly call on Tuesdays. Really, we've got individuals who are monitoring, contributing, coordinating. Coordinating is actually one of the things that I think a lot of participants get value out of, and then we're definitely looking at educational materials. We're working with other elements of SNIA on Bright Talks and whatnot. Active participants average about 1 to 2 hours per week, depending on whether you catch a work assignment or not. If you would like to reach out and contact myself for additional information, the email address is here. And I believe that's the last slide.
Thank you, Eric. Alex and Michael, updates from the SFFTA TWIG.
Hello, everyone. I don't think Michael is actually able to join today, so you just skip me. If you go to the next slide, I can give you some info on the SFFTA TWIG. So we are a relatively new group under SNIA. We've only been under SNIA for, I think, 3 years now. We are a group of about 70 member companies, and we manage over 150 active specifications. So we look a little bit different than a lot of the other SNIA groups. Our structure is a little bit unique as well. So we have the main TA TWIG, of which Michael and I both co-chair. And then we have 2 subgroups that kind of split up those 150 documents depending on their content. So we have the connector subgroup, which Michael and I also co-chair, and then the transceiver subgroup, which is chaired by Tom Palkert. So what do we do? SFF develops a whole bunch of different technical specifications over a really wide range of topics. So storage media, storage networks, pluggable solutions. You'll find a lot of specifications for cables and connectors, form factors, housings, as well as management interfaces, transceiver interfaces, and electrical interfaces. And one of the reasons that SFF is a very important part of the industry is we really help to ensure that technology is compatible across different vendors and that you can get multi-source products for your solutions. So it's kind of the inspiration to start SFF, and now moving under SNIA, we've got even a wider breadth of audience that we can reach, as opposed to just the days of the FTP site where we kept all of our standards. Next slide. So our list of past accomplishments is pretty lengthy. I mean, like I've said, we've got over 150 active specifications that we're still working on. So rather than dive into a rather long list of what we've accomplished, everything's available on our public-facing website as well as on the Causeway site if you sign up to be a member. The public site has all published documents, and then periodically we put drafts that we're looking for feedback from the industry on as well. And you can also get document status, so whether something is published, whether a new draft is being worked on, or whether there is a new project around that document that has been opened. In terms of future work, we are continuing to refine our process guide a little bit. We've got some tweaks and really just crossing some T's and dotting some I's and trying to make sure our process is really clear and runs as smoothly as possible. We are also continuing to update specifications and other documentation as needed. So we've got a couple documents that are currently open and are actively being worked on within the group. And basically that just gets initiated by an SFFTA Twig member coming forward and saying that there are some changes that are needed. And then assuming they have at least 3 other members' support, that kicks off a new project to start discussing changes to either a new document that's being created or changes to an existing document. Another big topic that is on our radar is potential collaboration with the PCI SIG on a next generation connector pinout. So we're still trying to navigate that one, but if you're interested in PCIe connector pinouts, come talk to us. Next slide. So as I said, we are over 70 members strong as of this month, so you can kind of get an idea of who we're talking to. We do have a pretty wide range of members, so we get input from all different aspects of the industry, which we think helps us make and write really good concrete specs. Next slide. And lastly, just to kind of put the call out there, we're always interested in getting more people to join and participate. We think that makes us stronger as an organization and makes our specs more technically complete. So by joining the Twig, you get access to all presentations and draft specifications. So like I said before, a lot of that material, at least in terms of the documentations for the specifications themselves, is available on the public site, but you don't necessarily get access to drafts, and you do not get access to presentations as they're made by member companies. So by joining the Twig, you get access to anything that's ongoing, as well as our library of past developments as well. And then I think most importantly, by joining the Twig, you get a voice in the document content and creation, as well as the comment resolution. So as we're writing these specs and making changes, it's a really good way to get your voice heard, as opposed to waiting for something to be published and made available and then maybe commenting on it after the fact. You can actually be part of that creation process. And then lastly, I just put a list of additional resources up here. So we've got our public site, the same link for all of our specifications on our public facing site. We also have our members site. So that's where if you do join, you'll find all of our past content, as well as some information about how to join and questions about membership. And if you can't find any of the answers for what you're looking for there, you can email Michael and I at the SFFTA Twig chair address at the bottom, and we'll be happy to answer any questions you might have.
Thank you, Alex.
Yeah,
appreciate
thank
it. On to Cheyenne for an update on one of the new twigs in the last year, the Smart Data Accelerator Interface twig.
Thank you. My name is Shyam Iyer. I'm the chair for the SDXI twig, also known as the Smart Data Acceleration Interface. So it's a new twig, and we are trying to propose something radical, which is a standard for a memory-to-memory data mover interface. And we have an elaborate charter and program of work that's in that link. Being a new twig last year in the middle of the pandemic, we managed to get this approved in July, had our first meeting in July as well. AMD, Dell, VMware contributed a version 0.7 specification as a starting point for this twig that gave us a good jump start. Post this contribution, we have kind of met weekly to review the draft specification, and it's gotten a lot of feedback through our members. As you can see, we have 18 strong members who have joined since the this new twig got formed, 42 individual members, and we also managed to do 2 keynote presentations, one at the STC conference as well as in the In-Memory Compute Summit conference, which you should go and see and learn more about our technology here as well. There is a proposal that the twig has adopted to be, passed to be adopted by the SNIA, CMSI initiative, which would help us with our outreach activities. If we go to the next slide. Then in terms of the work group items that we will focus on 2021, the list is pretty exciting. We will go ahead and finish our review process for the spec that we are reviewing currently. That would allow us to do a public review of that specification, at which point this would be available for folks to review it in the public domain. We plan to release a version 1.0 specification architecture document of this work, and also begin work on post 1.0 features. Because this document will be public in sometime in 2021, we would be able to do a lot of work evangelizing our work with podcasts, webcasts, conference presentations, and blogs. Also, we are looking at building an OS-independent reference software ecosystem for this particular data mover interface, so that different OS vendors can have a common base to work on. We're also looking at designing compliance testing tools that would help us interoperate with different operating systems. In terms of the SNIA group collaboration, we want to leverage expertise within SNIA groups around persistent memory, because we are a memory-to-memory data mover standard. We also think we can coordinate synergies with the computational storage work group, because we're also solving an important piece of the acceleration puzzle. So in terms of external collaboration, we think we can work with CXL and Gen Z groups in terms of seeing how this applies to a memory-to-memory data mover. That gives us an exciting lineup for 2021. We go to the next slide. As you can see, we are a small new group, but then we have been slowly and steadily growing our membership. It's got a motley group of companies, which includes CPU vendors, OS vendors, OEMs, memory vendors, drive vendors, acceleration vendors, and some more who couldn't make the deadline for this presentation. So I'm pretty excited for the excellent start that we have got, which brings us to the next slide. This is an important work for this industry. What we are doing here is creating an architectural standard for a data mover, and data mover which has been missing in our computer architecture today as a standard. What we have as a current data movement standard is basically CPU-based memcopy, which isn't sufficient for our increasing needs. So this twig is going to develop and standardize an extensible, forward-compatible, memory-to-memory data mover interface that's independent of any kind of actual data mover implementation that you may have, and also independent of the I/O interconnect technology that is needed to move from a memory-to-memory address space. So as you can see, that's pretty relevant to system vendors like OEMs and cloud providers, OS vendors, which includes hypervisor software vendors, end user ISV vendors, and hardware acceleration vendors, so they can build a common standard based implementation and then leverage that. Why you should join and participate? Because we are very early in our stage. As you can see, we haven't yet gotten our public spec out. So if you come now, you would have the chance to review, contribute, and also influence this important work that we need in our computer architecture. So if you would like to join us, please send us an email or contact us at the STXI Twig Chair at SNIA.org, and we would love to work and collaborate with you. Thank you.
My name is Don Deal. I'm the chair of the SMI TWG. Next slide, please. The SMI Twig has a charter to basically maintain and evolve SMIS, which is a standard that's been around for almost 2 decades now, that defines an interface for the interoperable management of a heterogeneous storage area network. And I believe it's still one of the few commercially available standard standards out there for managing equipment coming from different companies. It can be managed by a single screen. The work that the group did last year was primarily to create version 1.8 Rev 5. And what that did is it incorporated some change necessitated by some updates to the TLS specification and also refining some of the other portions of the spec. It's not a small spec at all. Like I said, it's been around for a very long time. And so there are 8 books associated with it for a total of something over 2,500 pages. So it's a significant effort that SNIA has been deeply involved with and pushing for a very long time. Anyway, the 1.8 Rev 5 technical position was in fact published on the SNIA website in March of last year. And then after some final adjustments for ISO, it was sent to ISO as a PAS submission in May. And since then, we've been monitoring the situation. Next slide, please. And this year, the group is primarily just tracking and supporting what SNIS 1.8 Rev 5 is doing as it progresses in ISO. Now, shortly before this call, I did hear from one of the ISO people that watches the situation for us, that is saying that all 8 parts have been approved with no comments or negative votes. And so what that means, it's now just in the ISO process for getting published. And I don't know how long that takes, but hopefully not very long. This is a significant effort for us, because what it does is it puts our best foot forward in terms of the SNIS specification. We are not expecting to create an additional version of this spec, but it's something we wanted to be our latest, greatest thing out there when it becomes the next international version of the SNIS standard. And often what happens is there are countries out there where they don't observe standards unless they're international standards. So this puts the latest and greatest version of SNIS out there. What the group will be doing this year, other than doing whatever is necessary to finish the ISO process there, is to help the Storage Management Initiative promote SNIS 1.8 Rev 5. Now, the Storage Management Initiative actually has a test program, a conformance test program, has been running that for a long time. It will be updated to handle the 1.8 stuff. And the standard itself, well, although SNIA does not plan to create additional versions of this spec, it's going to be around for a while because it is out there commercially available now. And using a standard is very different from the effort to develop the standard. Next slide, please. A lot of major companies have been involved with the development of SNIS over the years. This list is the list that's on the roster right now as of this month. And anyway, there's been a lot of deep involvement by some of the largest companies out there. Next slide, please. Industry impact. This has been one of the main things that SNIA started doing in terms of the standard it wanted to set. And it really does allow the interoperable management of equipment coming from multiple vendors. The companies paying attention to it and trying to implement it, and mostly the storage system vendors. There are storage management application vendors as well that create the things that can manage all this equipment that's using the same interface. And there are also storage client application developers where they have a specialized application that wants to manage its own storage, and they count on this too. So anyway, the SMITWG is basically winding down at this point because, as I said, we're not expecting to develop another version of this standard, but we wanted to make sure that what goes out there is our best foot forward. If you have any questions or want additional information about it, I'd be happy to talk about it. You can still join the twig if you wish, but we're probably winding up this year. Anyway, you can send a note to smitwig-chair@snia.org if you want more information. Thank you.
Thank you, Don, for the update. On to our last twig for today, the solid state storage twig. Eden?
Hi, this is Eden Kim. I'm chair of the S3 twig, and we're the last one for the break, so we'll be brief. Our charter was originally set to develop performance test specifications, which we refer to as PTS, for solid-state storage NAND flash-based SSDs. Over time, we've expanded to include real-world workloads and testing of persistent memory storage. Recent and completed and ongoing work, we had a follow-on to the original solid-state storage performance test specification with a real-world storage workload, PTS, for data center storage. We updated the SSS PTS for SSDs. We recently published a white paper introducing the next persistent memory PTS, and we are currently under development with the PM, or persistent memory PTS spec. Work items in 2021 are to finish the version 1.0, the PM PTS spec, which we should probably get done within a month or so. We are also in the process of listing various reference test platforms for different types of storage, which allows users to use these platforms and to be able to run the tests and get comparable test results, as well as listing reference real-world workloads on the CSMI S3 twig page. Collaboration, we collaborate with the IOTA twig, CMSI, and the NSF group and Green Storage. Next slide. We have about 8 member companies and individuals actively working, which is defined here as at least 9 times per year. We're currently meeting every week, and we'll do that until the end of February or early March. There's over 71 companies and individuals on the membership roll, but most of these are in observation mode or not that active. Next slide. So what is expected industry impact? The development of technical positions, reference test platforms, and white papers. Industry segments, relevance. We're relevant to the SSD OEM and ODMs, to controller and firmware designers, to data center storage vendors, and those involved in cloud application and storage optimization. Why you should join and participate? Well, beyond just monitor, contribute, and vote, you can see how synthetic and real-world workloads can be applied within and across different types of block, I/O, and byte addressable storage. You can contact myself at sssTwigChair@SNIA.org.
Thank you, Eaton. Thank you to all the chairs and to all of the participants this morning. I hope you found the presentations and updates very useful to give you a concise overview of recently completed technical work in SNIA, as well as the work in progress for this year. SNIA has a primary function of developing technology specifications and standards, and our technical work groups are the mechanisms by which we do that. We also serve a function of education and a function of advocacy for those specifications and technologies in the industry. We will now take a short 10-minute break, and we will continue with an update from our forum initiatives and committees to give you a perspective on the advocacy and enabling side of SNIA and the great work that is being led there by our chairs of the forum initiatives and committees.